Hello everybody, I'm an A-level mathematics student and I shall be going through the C1 polynomials test. The question that's been put to me is to find the coefficient of x to the power of 4. So what I shall be firstly doing is I will be writing the combinations down, the combination that's been given to me, and I'll be distributing the powers. And I have 2x to the power of 4 to finish. What I will then be doing is solving the combination. As we can see, this forms a slight bit of a problem. So I have 7c4, as stated above, and to solve this, I will have to turn this into a factorial. So I have 7 factorial divided by 7 take away 4 factorial into 4 factorial once again. This gives me, it would give me 35 as an answer, and what I now need to do is I need to go back to the original question and substitute 7c4 in. When I have expanded all of the brackets, what I'll be left with would be 4,375 multiplied by 16 to the power, so 16 x to the power of 4, and this gives me, let me actually write this down here, this gives me 70,000 x to the power of 4. Question number 2 now asks me to find the value of k within the equation, so k being the constant, and also finding a root of f of x. So firstly, you could substitute x for f of x, and I've chosen a variety of numbers. I started off with 1 and then minus 1, but I will now be substituting f of 2. F of 2 within the given equation would give me 4 into 2 to the power of 3 plus x into 2 plus 6. As they've given to me the remainder, I will note that down side by side, and I have 42 here. By the use of the remainder theorem, what I'll be now left with is 32 plus 2k plus 6, which gives me 42 once again. And therefore, k would equal to 4 over 2, which is equal to 2. So now I have the value of k. Let me erase all of this. Grab a big eraser. And what I'll now be doing is, since I do have the value of k, I will be inputting that into my new equation. So f of x gives me 4x cubed, and now I'll be substituting my value of k that we previously found. I've got 2x plus 6. What this would give me now, if I now start substituting values in once again, I would notice that if I put f of 1 in, I'd be left with 1 to the power of 3 plus 2 into 1 plus 6. And this does not give me 0. So once I've replaced the value of x and substituted it with another number, if the answer is not 0, it cannot be a factor of the given polynomial. However, if I do input minus 1 in, what I have now is 4 into minus 1 cubed plus 2 into minus 1 plus 6, which gives me 0. The question requires me to give an answer of a root of f of x. So therefore, what I'm left with is x plus 1 would give me 0, and therefore x is equal to minus 1. So minus 1 is a root of the polynomial. The equation rather in this case, because I can't fit it in. So now on to question number 3. It asks me to find the minimum point of the parabola as well as the line of symmetry. So firstly, for the minimum point, what I'll have is for y, I will substitute it with x minus 4 whole squared. Let me stick that on, which is equal to 0. Therefore, from this, when I solve it, I will find that y is equal to minus 3. Secondly, for x, I know that x minus 4 is equal to 0, and therefore x is equal to plus 4. So now my coordinates are 4 and minus 3. They've also asked me for the line of symmetry. Now, if you notice, the graph looks slightly like this. And what my line of symmetry needs to do is reflect the parabola. So I need to cut the parabola in half and make sure that it would look the same on both sides. If I split my graph around the middle, I need an exact point somewhere over here that would cut the graph into two, and I'd have the same shape on both sides. And if we see that this would all derive from my minimum point, by the way, that this point on the graph right here would be x is equal to 4. Because if I draw a line right here and I label this 4, I have exactly the same graph on both sides. And so that's my answer. So x minus 4 would be the line of symmetry, and you can stick that in, obviously, as a conclusion. Right, now for the points of intersection of the parabola, I would need to firstly for y, I'd sub x as 0. So what I'm left with now is y is equal to 0 minus 4 whole squared minus 3, which is equal to 13. Right. And for x, I'm going to write it a bit smaller. For x, I'll sub y as 0. And therefore, what I have left is x minus 4 whole squared minus 3, which is equal to 0. What this will now leave me with is x squared minus 8x plus 13, which gives me 0. The trouble is that if you do apply the ACB method, where you find a and c, so two numbers to multiply that would give you AC, and one number that would add or take away to give you minus 8, you would have a slight problem, because whatever the outcome of it is, they would never you wouldn't know the specific numbers that would make minus 13, and you wouldn't know the specific numbers that make minus 8. So in a case like this, what I'll be doing is I'll be applying the formula. So the quadratic formula is x is equal to minus b plus minus the square root of b squared take away minus 4ac over 2a. And what this leaves me with is, when I substitute it, I have minus 8, plus or minus again. These signs are extremely important, the plus or minuses. And then I have the square root of minus 8 whole squared minus 4 into 1 plus 13. And all of this will be divided by 2 into 1. What you're going to be left with are the coordinates for the intersection with the y-axis. That, as we previously noted when we subbed it, so when we subbed the value of x as 0, we were left with 13. So when x is 0, y is 13. That's the y coordinate. And when you solve this quadratic formula, what you'll be left with is the x-axis coordinates. So the x-axis coordinate would be 8 plus or minus, let me make this plus better, the square root of 12 divided by 2, 0. So that would be for the x coordinate. And that's that question solved. So this is question number 3, part 3, and it's a slight bit different from the rest in the sense that it's asking me to prove a certain outcome. So I've been given the task of translating the graph by the given amount they gave. I believe that was 2, 0. And so first of all, I'll start off by writing the facts. Let's just box that off slightly. I know that y is equal to x minus 4 whole squared minus 3 because of my previous calculations of completing the square. If the graph has been translated by 2, I know that my graph right now would be x minus 6 instead. So I've shifted it 2 units to the left. That's why I've added another minus 2. And the same would apply. All I'm now going to do is expand my answer. So x times x gives me x squared. Minus 6 times minus 6 gives me a positive 36. And the rest would be minus 2 into x into 6 minus 3. And this would give me the answer of x squared minus 12x plus 33. Which is exactly the same as the answer given on the page. So, hence, proved. So, this is my final question. The question I've been given is that the value of y is equal to 8 minus 2x, and I've been given another equation where y is equal to x squared minus 12x plus 33. Let me just draw a slight line underneath that. Right. So I know that the value of y is 8 minus 2x, and I also know that the same value, y, also gives me x squared minus 12x plus 33. What I'm going to do, for the sake of ease, for both myself and you, I'll be subbing or substituting the value of y into my equation 2, so my second equation. So now what I have left is 8 minus 2x, which gives me x squared minus 12x plus 33. It's easiest if you change it into a quadratic. So by a quadratic, it's already in a quadratic form, but I mean having a 0 on one side would make it much easier for everybody to solve. So I will stick a 0 on at the end, and I'll take everything else to the other side. So what I now have left is x squared, yet again, minus 10x this time, because I've taken away x on both sides, but minus 2x on both sides, and plus 25, because I have taken away 8 from both sides. What I'm left with now is x minus 5, and again, x minus 5, when I factorise it. So after factorisation, x is equal to positive 5. And what you'll notice about this is x is a repeated root. So do write the answer down below. So x is equal to positive 5 as x is a repeated root. And so you'll see that the only answer you could have obtained was positive 5. You were never able to get negative 5 because you do have a 0 on this side. So for the sake of clarity, in fact, let me erase this. So for the sake of clarity, we had x minus 5, which is equal to 0, and x minus 5, which is also equal to 0. So x is equal to positive 5 when we take it to the other side, this over here, and this over here. So, and x is equal to positive 5. You could never obtain negative 5. And the idea of a repeated root is that you should have the same answer. If, however, you don't have the same answer and one of these turns out to be a negative, this is a repeated root. A repeated root would be a root that gives you the same answer And by answer, I mean the same number as well as the same sign, and that's how you know you're right.